One of the things for those of you who are new here, we have a thing we call a challenge, and there's 3 phases to this. One is just build a robot that'll push a box off of the table and not fall off itself. Let's see. I guess the first one is just not fall off at all.
Go from one end of the table to the other.
One end to that. Yeah, one end to the other. Getting it straight. Done that. Okay, one end to the other, and then the next one is to
Push a block
take
off
a block
the edge.
and push it off somewhere and not fall off yourself. And then the next one is to put that block into a box. And there's pretty loose rules, so you can define what a box is, you can define what the size of the box is, most everything else. So this is using an Arduino 2560, and I've used this before and been successful, but I keep screwing around with this thing, doing other things with it. My latest thing is to learn how to use the interrupt system, and Richard has said he's going to help me with this a little more. I've also added, since the last time you guys saw it, is I've added a serial 2-line display unit here, and which is kind of weird. I still don't understand why it is, but off of the serial port, you can use the serial driver and drive this thing. However, it likes to you need to flip the thing upside down. Now, I've always to design something. Why that's true, I don't know, but anyway, I've added a little transistor here that flips the signal upside down, or in my case, right side up, and so that I can use the serial driver, and I can kind of see what's going on up here. Okay, now, this doesn't travel all that well, so let's see if it's working now. And I've been through all this. And get it going here. Back. Okay. So here's, at least hoping. I've been trying to figure out, the interrupt system is kind of squirrely on this thing, in my mind at least, is you can't spend any time in the interrupt itself. You got to get the interrupt, set a flag, and then get the heck out and go do something. So it looks like it at least tried to find the box there. And it doesn't find one of you guys. Uh-oh, that wasn't a good move. Okay, like I said, this thing is kind of squirrely.
Asterisk.
Yeah, right, asterisk. Let's see if it does that again. Give it a little direction.
What's the robot's name, George?
I don't know. I think it's something.
What you should call him?
Okay,
Just call him
one
squirrely.
of the problems is it picks up. One of the problems is it picks up everything out. I got let's see, I've got 5 points that I attempt to pick up. Now it should turn left. Oops, it did. Okay, watch this. We'll make it turn left. Okay, don't think I'm going to qualify tonight. Now,
It's all right.
one of the things I found is that for some reason or other, this particular unit, I have a feeling bleeds. You know, keep moving it down.
Why did you push it right in the box?
This ping unit, it appears to be a bleed signal. And I tried curing that. Yeah, see that? It does that fine. For some reason or other, it appeared to be bleeding the sound. I was getting some false readings, so I took a glue gun and put the hot glue around the receiver and transmitter. Now, there you go.
Ted Larson would be proud.
Okay. So now watch it do something different and push it off somewhere else. At least that would qualify for the next one, right?
Think positive, George.
Yeah, right. Let's see what it does.
You can do it, squirrely.
That was phase 2.
That was phase 2, right?
Meant to do that.
Yeah, it was intentional.
Now, let's see what happens here. See that? That's the interrupt system picking up the mechanical switches here. One of the things that I've found is when you try to use things like IR detectors and things like that, you're never quite sure what the table is going to be when you come in here. Okay, so it's trying to figure out why that leg is hanging off over there. Okay, as you can see, I still have some work to do on the coding here. Richard's going to help me with the coding here. Anyway, I've learned a lot, and it's been a good little platform to play with. There you go. Now, here we go. Now it's looking for the box again. Okay, so we try this one more time here. Okay, let's just try. Like I said, I've tried bending this thing. I've tried doing all kinds of funny little things, and trying to figure out how to get it to pick up the box and go to get the box seems to be one of my hardest problems, and I'm not real sure why. I set it up with. I see that. No telling why it decided it wanted to do that. Now, let's see if it goes forward or not. One more time, real quick. Okay, let's get it going here. Okay, let's try to get a little closer and see what happens. Okay. Okay, I see it probably saw me is the trouble. Okay, one more time, now I'll quit. Okay, so how many of you are into Arduinos? See, there's lots of Arduino stuff. You can get Arduinos for as little as $10, and they're a pretty fun little machine to play with.
$3.
When you get down to
You have to wait for 6 weeks to get them, though. But.
Yeah. 7 for working.
And flip a coin if they show up.
Okay, I'm going to quit here. If this thing doesn't go, doesn't find the box, I'll quit.
Come on, Squirrely.
Now, see, why does it not find the box? Okay, I'll quit.
Because you're demoing. There's always next time. We'll be back.
We'll be back. There you go.
Okay, Ralph is going to show us something. I do not know what it is.
Okay, this is a Raspberry Pi. It's connected to 2 I2S amplifiers and speakers, and there's 2 I2S MEMS microphones as well, although I only have the speakers working at the moment. So if all works well.
Front, right, front, left, front, right, front, left, front, right, front, left, front, right, front, left, front, right, front, left.
So that's all it's doing at the moment. It's just outputting a signal to each left and right speaker. And the main reason why I wanted to do this was so that I could have an artificially generated voice, you know, text-to-speech, and have a nice clean output as opposed to the standard Raspberry Pi headphone jack output, which is very, you know, low-quality audio. And then with the stereo microphones, I hope to do sound location so that, you know, if there's somebody speaking, you'd be able to recognize their voice, but also be able to turn your robot to face the person who's speaking. And so that's a work in progress, and hopefully you'll get to hear more in the future.
So what is this board?
It's a Raspberry Pi plus 2 I2S microphones and amplifiers from Adafruit.
Okay, those are the
But is that a separate board or a
Yeah,
hat?
you can come see it at the break or whatever.
Is that a hat that you're putting on the Pie? Or?
Well, it's
random wire.
not so elegant as a hat.
Floating in space.
You can see that my finger to give you a scale there. It's just a little tiny chip on a breakout board, and then you know your 10th inch male female jumpers to wire it up.
This is very easy.
Where did you get the voice?
Where does the I2S come off the Raspberry Pi then?
So the I2S comes off one of the pins, or 3 of the pins on the Raspberry Pi's header.
Okay.
And the voice comes from the standard ALSA speaker test program.
I2S, not I2C?
That's correct. It's similar. I mean, it's got a clock. It's got a left-right signal, so it does stereo, and then it's a serialized data in and a data out wire.
Does the Pi have both input and output override to it? Or
Yes. That's why the microphones as well as the speaker. Okay?
What model Pi did you use?
It's Raspberry Pi 3. But most any of them will work.
Just a quick question about the library you're using for the audio direction finding.
Haven't gotten that far yet.
Work in progress. Okay,
All right, thanks.
very good, thank you.